Hello students, welcome to this lecture in which we're going to talk about, continue our discussion about conservative vector fields. And the first theorem we're going to discuss is the following one. It says that if f is a conservative vector field, and if C is a closed path, and piecewise smooth path, then the line integral of f dot dv is equal to 0. So I'm not going to give the details of the proof, but the idea is really simple. You have to apply the fundamental theorem of path integrals, and you have to notice that if the path is closed, then f of a is equal to f of b, and so the difference will be 0. So it will give you 0 on the right side. That's all you need to do. So no actual proof, but it's one really easy one. Just the idea is really simple. So one thing to notice is that to use the fundamental theorem, of line integrals, we need to know whether f is a conservative vector field. And if it is, we need to be able to find f such that the gradient of f is equal to big F. All right, so that's the interesting thing that we have to notice. So let's try to elaborate on this idea. So suppose that uppercase F is given by P and Q, and it's equal to the gradient of F. then we can think like this. We can say that p has to equal to the partial derivative of f with respect to x, and you can notice that q has to be the partial of f with respect to y. And we have to recall that by Clairaut's theorem, Clairaut's theorem says that if the cross partials are continuous, then they're equal. And this means nice, right? We said nice, but actually Clairaut's theorem claims that if they're continuous, then they're equal. So that means what? If we take p and take a partial with respect to y, which will be the derivative of f with respect to x, this would be exactly fxy. And at the same time, if we think about partial of q with respect to x, that's the derivative with respect to x of df with respect to dy. So this would be fyx. So conclusion, therefore, if p sub y is not equal to q sub x, then f is not conservative. Okay. And another conclusion, if the partial of p with respect to y is equal to the partial of q with respect to x, and if the partial are continuous, if the partials are continuous, then f is conservative. We need an extra condition that partials are continuous. So then f is conservative. So, small question. In particular, can we make this determination and can we calculate f? Can we make this determination and can we calculate f? That's the question, and to answer this question we have to look at a particular example. So in our example, we have a line integral of 10x to the 4 minus 2xy cubed dx minus 3x squared y squared dy, where c is given by x to the 5 minus 5x squared y squared minus 7x equal to 0 between 0, 0 and 3, 2. All right. So let's look at this example. We know that P is a part in front of x, so which is 10x to the 4 minus 2xy cubed, and Q is in front of dy, so it's negative 3x squared y squared. Then partial with respect to y will be negative 2 times 3, so it's negative 6 x times y squared, and partial of q with respect to x will be negative 6xy squared. So this function is continuous, this function is also continuous. Conclusion, this p sub y and q sub x are equal and continuous. Therefore, fundamental theorem of path integrals applies, and we only need to find f. That's all that left for us to find. So what do we know? We know that the gradient of f is equal to p comma q, which is 10x to the 4 minus 2x cubed for p and negative 3x squared y squared for q. And at the same time it has to be partial of f with respect to x and partial of f with respect to y. So if f of x is equal to 10x to the 4 minus 2xy cubed, then what? Then we have to say that from this part over here, we say that f is equal to, so we find antiderivative of this function, so it's going to be 10x to the 5 over 5 minus 2x squared over 2y cubed, and then plus some constant that can depend on function y, because if we take derivative of this function that depends only on y, we're going to get 0 because we should add constant, but this constant can depend on y here. So we write g of y here. We'll write g of y. And if we simplify it by dividing 10 and 5, we're going to get 2x to the 5 minus x squared y cubed plus g of y. Alright, so now we've used partial of f with respect to x. Now we're going to use partial of f with respect to y, which is negative 3x squared y squared. So part B tells us that according to this, if we calculate antiderivative of this function, we're going to get with respect to y. So negative 3x squared y cubed over 3 plus some function that depends on x. Right? It's like a constant because if we take derivative with respect to y of this h, we're going to get 0. So we simplify it, so we're going to get negative x squared y cubed plus some h of x, The next question we should ask, can these parts a and b represent the same function? So let's write it out. Can a and b be two representatives or two representations of the same function, function f. That's our question. So what does it mean for us? That means this should be equal to this. So let's do this out. So we take 2x to the 5 minus x squared y cubed plus g of y has to be equal to this. So negative x squared y cubed plus h of x, So let's try to match things up. So we can clearly see that the middle just matches up completely, and this has to be function of x. So that means this has to be a match. This has to be a match over here. Has to match up. Unfortunately, there is nothing to put g of y equal to, so g of y then has to be equal to 0. That's our representation. So finally we say that f of xy has to be 2x to the 5 minus x squared y cubed. And we're ready to take the integral. We're ready to take the line integral. So we say the line integral of some function here that dv is equal to the line integral of some function which we're not sure yet, that dx dy. So that's our dv. But then the fundamental theorem tells you it's really easy to do. You don't really need to figure out this part. You just have to take and set it equal to f of b minus f of a. And this is your f. So you just say 2x to the 5 minus x squared y cubed evaluated from the initial point 0, 0 to 3 over 2. And you get 2 times 3 to the 5 minus 3 squared 2 cubed. And if you plug in 0, you're going to get 0. And that's going to be your answer. This is going to be your answer. And probably a good place to stop this lecture. See you in the next one.